So in today's session, we are going to take the architecture of Splunk, how exactly it looks like, and how the data flows from one end to another end. So whether you are acting as a developer or you are acting as an administrator, everybody should know the architecture of Splunk, how the data flows from one end to another end, right? So let me draw few boxes before I go ahead and explain you the architecture. Okay, so these are the boxes, uh, and before that we have few components of Splunk. Components of Splunk in the sense, let me, okay, components of Splunk. Number one, universal forwarder. What is the meaning of each of the components? I'll let you know, but let me write each of the component one by one. Heavy for.
Uh, your voice is not that audible now.
Okay, just hold on for a moment. I don't know why it is happening, but is it okay now? Hello?
Yeah, it's okay.
Okay,
Yeah, it's okay.
yeah, fine. So heavy forwarder. Okay. So what I'm saying is, let me write down the name of the components one by one, and then I'll explain you about each of them. Okay. Indexer. Search. So let me draw a few more boxes. And architecture detail. Okay, this is the architecture of Splunk. With the help of this component, I'm going to create my architecture. I'm going to explain what exactly the architecture of Splunk is and how the data flows from an application server to the Splunk injector or the Splunk server. Now, let's say this is one application server which is kept in Australia. This is one application server which is kept in India. This is one application server which is kept in Bangladesh. And this is one application server which is kept in US. So we have four different application servers kept in four different locations across the globe. So what do you mean by application server? Server is something like a laptop or a computer, right? So in your laptop, in a computer, there is a software running. So that software is known as an application. So hence that server will be known as an application server. So if any application is running in a server, it tends to generate some kind of logs. So that log will be generated and will be kept in some path, right? So this application server will generate a log, this application will generate a log, this application will generate a log, and this application will generate a log. So four application servers are kept in four different locations across the globe. Me, Abhay, which I'm saying, is sitting in India. Now, I want to, so the first step of Splunk is to collect the data. I told you in the slide itself, how will you collect the data? So, I am sitting in India. Being in India, I would like to collect the data from the different application servers which are kept across the globe, in a different location across the globe. I want to collect the data. So in order to collect the data, what I'm going to do, there are two things. So what are those two things? Push, 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 and pull. There are two mechanisms. Okay, I hope you can see my screen. There are two mechanisms. So Splunk works in a push mechanism. It does not work in a pull mechanism. So it works in a push mechanism. It does not work in a pull mechanism. What do you mean by pull mechanism and push mechanism? Let's say Krishna has got an audio file in his computer, in his laptop. in how many ways that audio file can come to my laptop. In how many ways? There are two ways. Push. If Krishna follows the push mechanism, then what is going to happen? Krishna will push that audio file to my laptop from his laptop. He will give it to me. He will come to my home and he will say, Abhay, you check this audio file which you have asked for. So this is a push mechanism. The one who has the file, he is pushing it to the others. Now what is the pull mechanism? I am sitting here. I will log into, I will go to Krishna's flat and I'll say that Krishna, you have this audio file in your laptop. Could you please give it to me? So this is known as pull mechanism. I need it. That's why I went to Krishna, right? In Splunk, there is no pull mechanism. There is always a push mechanism. Push mechanism in the sense, let's say Krishna is in Australia, then the other guy is in India, and the other guy is in, you can say, America, and the fourth guy is in Bangladesh. So four people are sitting in a different location. I want to get a file from all those four servers in my laptop. So I cannot go to them and get the data from their laptop. Instead, they have to send their data to my laptop from their location. You got the point? So always push mechanism is valid in Splunk, not the pull mechanism. Fine. In order to get the data from the different application servers, we will install Universal Forwarder HF, which is nothing but our first component of Splunk. Okay, there is no order, but if you keep the things in order, then it will be easy for you to understand the architecture of Splunk. Universal forwarder, and here also universal forwarder. What is universal forwarder? Universal forwarder is nothing but a Splunk instance. It's a very lightweight version of Splunk, very lightweight version. It does not have any special capability to do anything in Splunk, except forwarding the data. You got the point. So universal forwarder is a small instance, is a lightweight version of Splunk, which takes the data from one end and forwards the data to other end. Which takes the data from one end and forwards the data to the other end. Let's say if I want to get the data from Sumade's laptop to my laptop, I will install universal forwarder to Sumade's laptop. It's very simple. So, and I'll configure in such a way that data will be collected from Sume's laptop and it will be forwarded or pushed to my laptop. That's it. So this is known as universal forwarder. Now, I have a concept of load balancing here, LB, which we call it as a load balancer. So I hope you know about load balancer. If not, then also it's okay. Load balancer is something like the name, the name itself can explain what exactly the load balancer is. Load balancer is a device or is a feature which balances the load. Let's say under me, three people are working. Okay, person one, person two, and person three. So three people are working. Now I am acting as their manager or I'm acting as their tech lead. I have got a task from my manager and this task has to be done immediately or by 5 o'clock in the evening. So to whom I'm going to assign this task? I'm going to assign this task to the one who is sitting idle for a long time or who has less work among themselves. Let's say if I'm going to the employee one, he's working on some task. So I'll leave him. I'll go to employee two, he's also working on some task. I'll go to employee three, he's also working on some task. So all are working on some task. So in this case, I will check who has got less tasks to do, right? So the one who has got the less task to do, I'll assign this task to him. Everybody is working, but still I'll assign this task to him because he has a less number of tasks to do, right? So this is a kind of a load balancing. I'm balancing the load. If I assign this task to somebody who has already a lot of tasks to perform, then it's a kind of an injustice. Got the point? So in Splunk, when we use the load balance, it does the same stuff. So the data comes from this application server to this server through load balancer. Okay, so data comes through load balancer to this server. Okay, The data is coming from this application server to these two application servers, I mean to these two servers to load balancer. And the same thing is happening in this case as well. So it means the data from these four application servers are coming to these two servers. Now, what are these two servers? In these two servers, I'm going to install Heavy Forwarder. Heavy Forwarder is nothing but the second component of Splunk, Heavy Forwarder. Now, what is Heavy Forwarder? Heavy Forwarder is also a Splunk instance, but it is a full version of Splunk. Okay, it is a heavyweight version of Splunk. Heavyweight version of Splunk in a sense, not only it can only forward the data from one end to another end, but also it can do a lot of stuff with the data. If you remember, in the first slide itself, I explained you that Splunk is a licensed version software, and the license of Splunk depends on how much data we are indexing per day, right? So how much data we are indexing per day. Let's say it may happen that I have purchased a license of 10 GB. Just focus on this particular topic. I have a license of 10 GB per day, okay, from Splunk. Now, these application server, this application server, this application server, and this application server all together are generating 100 GB per day. How much? 100 GB per day, because these are the huge servers. Now, if I take all the 100 GB to my Splunk server, it means it is going to violate the license capacity, right? I cannot store more than 10 GB per day license. Otherwise, my license will be violated. So in this case, what I'm going to do, there are two workarounds for this solution, for this problem. Number one, I'll go to the Splunk people and I'll ask something like, boss, I have got 100 GB per day, 100 GB data per day is getting generated in my environment. So could you please give me 100 GB license or 120 GB license just to have a 20 GB in buffer size? We can do that as well. But for a small scale industry, budget is the main issue, right? So you don't have the budget to go for 100 GB license per day. So that's the reason you have a budget only to go till 10 GB license per day. So what you are going to do, you will filter the data before it gets stored in the Splunk server. Okay, you will delete all the unwanted data which is not required by your business, so that filtration and the parsing of the data is done in the heavy forwarder. This one. So what it does, when the data comes from universal forwarder through load balancer to the heavy forwarder passes the data and filters the data. Passing the data in the sense, let's say your application server is sending a log of the bank details, sending the log of an employee information. So you can have a PAN card, SSN number, passport number, you can have a credit card number. So client does not want the credit card number to be stored in the plain text in the Splunk server. So before it gets stored in the server, the number has to be marked with XXXXXXXX something. So this can be done here in this level. Parsing can be done in this level, HF. Now, you have 15 fields altogether for some data. So out of 15 fields, you do not require all the 15 fields to be stored in Splunk. Instead, you only want 3 fields or 4 fields. So this is known as filtering. So you can filter the data in heavy forwarder itself. Okay. There is one more example of the filtering, that you have got the data. Let's say in a log file you have 100 lines, and related to error you have only 5 lines. So you only want to capture the error information. So other than error information, you do not want to capture any lines. So what you are going to do, out of 100 you are only capturing or storing 5 lines. You are discarding the unwanted 95 lines in heavy folder itself. Okay, like this we will put the business logic to parse and filter the data in the heavy forwarder itself. So heavy forwarder has a capability to parse and filter the incoming data. And since it is known as a forwarder, it also forwards the data. It can also forward the data to other ends of Splunk architecture. So after parsing and filtering, the data is forwarded through load balancer to these servers. Okay. What are these servers? This server is nothing but indexer, IDX, 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 and the last one is also IDX. It means we have 4 indexers. Indexer, okay, just now don't get confused with the name indexer, INDEXER. Why I'm saying like that? Because we have a concept called index as well, which we are going to check in the next section. But in this section, you just know about indexer. What is indexer? Indexer is nothing but again a full version of Splunk. It's a heavyweight version of Splunk with all the features enabled. And this is a place where Splunk gets stored. This is a server where Splunk gets stored. I'm sorry, the data gets stored. I'm really sorry for that. This is a place where data gets stored, right? So data was in the universal forwarder. Data was in the application server. So with the help of universal forwarder, we took the data in the heavy forwarder. In the heavy forwarder, we parse the data and we filter the data. We only forward the wanted data to the indexer, to the load balancer. Now the data is stored here. Okay, now the data is stored here in the distributed environment. So everything is good, everything is fine. We are pretty good with the data storage. Now we want to see the data which is stored in the indexer. So we need to have an environment through which we can see our stored data. Now that's why we will have these 2 boxes. These are known as search heads, SH. These are known as search heads. Search heads are nothing but again a full version of Splunk instance, right? It enables, what is search head? It enables graphical user interface for the end user to see the data which is stored in the indexers. I repeat, it enables the graphical user interface for the end users to see the data which are stored in the indexes. So each of the search head will be connected to the indexes. Okay, will be connected to the indexes. So the same thing will happen to here as well. Okay, done. Right now, in universal forwarder, we do not have graphical user interface. Just mind it. In universal forwarder, we do not have the graphical user interface. It's a lightweight version of Splunk, which takes the data and forwards the data. It does not do anything else. Since the heavy forwarder is a full version of Splunk, is a heavyweight version of Splunk, it has got the graphical user interface as well. But in the heavy forwarder, in the indexer, administrators always disable the graphical user interface after configuring it. So at the time of configuring the server, they might use graphical user interface and they might not use graphical user interface. If they're not using graphical user interface, then they will probably go and make use of CLI, which is command line interface, to configure their servers. Okay, in most of the companies, big companies, they don't even touch graphical user interface to configure their server. You got the point? Because they will already disable it for the security purpose. Just they will keep the graphical user interface of the search head enabled so that end user can easily see the data which is stored in the indexers. Right? Now, everything is done. Now, let's talk about license. License is something which we have to purchase from Splunk.com depending upon the size of the data we want to store in our indexer per day, right? So we have to make one server as a license master. So this is LM. What is license master? When we go to the Splunk to purchase a license, they will give us a small file with extension .license. They will give us a small file with extension .license. LICENSC. You got the point. Something will be written over here before the dot, and after dot license, it will be ended with license. Now, this file is a very small file. Got the point? This file is a very small file. Let's say if I have purchased 10 GB license per day, it is not, I mean, it does not mean that my license size will be here huge. Okay, the size of the license file will remain same, 2 KB or 4 KB. But if you open this .license file in a notepad, you could see a small XML configuration, XML coding. In that XML coding, you will find a small key written in between. It is an encrypted key. So that encrypted key indicates that this license is of 10 GB. If you open a 100 GB license, that file will remain same, 2 KB or 4 KB. But if you open that license in a notepad, you could see there's a small encrypted key written in between, which resembles or which indicates that it's a 100 GB license per day, right? So what is license master? When you purchase a license from Splunk.com, you have to upload this license in a separate server. Upload this license in a separate server. The moment you upload this license will become a license master. Okay, this will become a license master, and you have to configure each of the component. You have to configure each of the components as a license slave. Okay, you have to configure each of the components as a license slave. Slave in the sense, each of the component will point to this master. Each of the component, since they are working as a slave, they will point to this master. Okay, because why this master? Because this is a place where we have uploaded our license file. Now you think about one stuff. For just uploading a small file in a server, why the hell we require a separate server? Because if we are handling or we are having a separate server, then we have to go for the maintenance cost, right? We have to check for the RAM, we have to check for the CPU, we have to have, we need to have a highly configured server, so we have to pay the cost for that particular server just to upload a small file. This is not fair enough, okay? It is going beyond of our expectation. So what we can do, instead of having a separate server for having a license master uploaded in any of the search it, let's say in this case, let me change the color. Let's say in this case, in any of the search it, we will upload the license master. That's it. In any of the search it, we will upload the license by going to settings, license, browse, and then browse the .license file from a local drive, and okay. So this will become a license master. This is a search it, as well as this will also act as a license master. Okay. Now, the most important stuff is the deployment server. This is known as deployment server, DS. What exactly it does? Now, this is a very important concept. Try to focus on this topic. Let's say for the time being, I have 4 servers, application servers. So in this application server, as I said, it can take the data and it can forward the data to the further boxes or further servers, these 2 servers. How this server will come to know that it has to forward the data to these 2 forwarders? How it will come to know? It means we have to write something here, in the sense we have to give the IP address of these 2 servers to this universal forwarder, right? Then only it will get to know that, okay, boss, I have to forward the data to these 2 servers. So here also, in this server also, at the time of the configuration, at the time of the configuring universal forwarder, we have to provide the IP address of these 2 servers, right? Then only this server will come to know that it has to send the data to these 2 servers. and the same thing will happen here, and the same thing will happen here. It means the IP address of two heavy forwarders are defined in the universal forwarder servers, each of the universal forwarder servers. Now you think, let's say after a couple of months being in the environment, you have got a requirement to
So
add.
I have one question here, Vikram.
Yeah, sure, please.
So you said like we have to set the IP address of the
Heavy forward.
heavy forwarder
Universal
in
forwarder
the
configuration file. Yeah, true.
yeah. So we set that as a is that will that be a static or dynamic?
No, it will be static. It will be static. It should be static.
Okay.
Yeah, it cannot be dynamic. It should be static. It should be hard coded.
Okay, because it is going through the load balancer, right? So
Yeah, see, there are two kind of load balancer we can use over here. One is the hardware load balancer, which is taken care by the admin team, right? And the second one is the software load balancer. So Splunk itself has a feature to provide the load balancing stuff. You got the point? So most of the time we go for the software load balancer. I mean, you have to write a small value in one of the configuration file so that the load balancer will be automatically enabled. But IP has
okay,
to be static in this case. Even if you are going to give the load balancer, I mean, let's say you are using a hardware load balancer. So you will provide, let's say, so the load balancer will be taken care by the Unix team. So let's say Krishna is in the Unix team. He takes care of the load balancer, right? So I would request Krishna that Krishna, I want to send the data to IP1 and IP2. I will provide IP address, these two IP address to Krishna, and also I'll provide the port number to which it gets connected to. So port number and IP, these two information I will provide to Krishna, the Unix administrator. Now he will set up these two in his load balancer. You got the point, but it has to be static.
but you said like based on the load in the two forwarders, like it or two servers, it will choose the server which has minimum task, or based on the priority it will choose, right? So
Right,
that's
right,
why
right.
so in that case it should be dynamic, right?
No, the IP. No, 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 no. You are not getting my point. See, okay, just try to understand in this way. You three guys, Gokul, Krishna, and Sumed are working with me. Fine. Okay. So today you are working with me. Tomorrow the employee will not get changed. So tomorrow if I get a task, I'll see who is sitting idle for a long time. So Gokul is sitting idle for a long time. So I assign this task to him. Tomorrow if I get another task, I won't see different employees working under me. I will see the same employee, right? Gokul, Krishna, and Sumed. You guys are not going to change. So in this case, load balancer is balancing the task, but the IP will remain same. You are getting the point.
Okay,
The IP will remain same.
okay,
Yeah, so it's a static IP. So I mean, if the IP is not same, how load balancer will come to know where to deliver the task? You tell me one thing. If IP is not same to the load balancer, if the IP is not known to the load balancer, if it is dynamic, then how load balancer will come to know which IP this heavy forwarder has got today or tomorrow? What is the IP for this heavy forwarder? It cannot easily recognize the heavy forwarder's IP address by its own.
okay.
Got the point? So IP address will be static. Then I know two addresses. Now, depending upon the load, the idle time, I will distribute my load. That's it.
Okay, got it.
You got the point? Right.
Yeah.
So I hope I made myself clear to you. Hello.
Yes, Vikram.
Okay.
Yes,
Okay.
Vikram.
Yeah. So in this case, I have got. I mean, I have defined two heavy forwarder IP address here, two heavy forwarder IP here, two heavy forwarder here, two heavy forwarder here. Now, in my case, I mean, we had some discussion with the senior manager, and it was well decided that okay, instead of having two heavy forwarders, we are going to deploy two more heavy forwarders. Okay, we are going to deploy or we are going to add two more heavy forwarders in our architecture. Now, how this universal forwarder will come to know that I have to send the data to these two heavy forwarders? How it will come to know? It means instead of having 2 IP addresses here, we have to add 2 more IP addresses, right? In the configuration file. So here also I have 2 IP addresses. So I have to add 2 more IP addresses for these 2 newly added servers. So here also I have 4. Here also I should have 4, right? Now, if in order to do this task, how I'm going to do this? I'll connect to this server through putty. Okay, this is me. I'm sitting in a desk. I'm sitting in a desk. Here I am working. So from here, I will connect to the server through putty. Putty is a small software in Windows through which we connect to the Linux server. I'll connect to this and I'll add these 2 IP addresses for the newly added heavy forwarder. Again, I'll come out. Okay. Again, next time, again, I'll log into this server. Again, I'll add these 2 servers and again, I'll come out. Like that, I will do 2 more times. I mean the 4 times because I have 4 application servers. Assume that if we have 4, we can easily do it manually, logging, editing, coming out, logging, editing, coming out. But let's say if we have 100 of application servers, if we have 10,000 plus application servers, then what we are going to do? Then manual task is not efficient, right? So instead of going and logging to each of the server and updating the configuration files, what we are going to do, we are going to make use of deployment server. We are going to make use of deployment server. In the deployment server, what exactly we are going to do? We will install Splunk full version over here, which is a heavier version of Splunk, and we will configure this as a deployment server. It means we will configure a small configuration file with all the 4 IP addresses of heavy forwarder only once. So we will configure only once and then we will push it from here. We will push it from here to all the deployment clients. So if this is working as a deployment server, all other servers will be acting as a deployment client. So instead of logging manually to all the 1,000 servers and edit the file and then log out, we will only configure once, and from here we will push the configuration files to all the 1,000 application servers, right? So isn't it so easy? I mean, just make the change in one place and then push it from here so that the change will be reflected to all other servers, 1,000 servers or 10,000 servers, it really does not matter. So deployment server is...
Vikram, sorry for interrupting. Can you please repeat that deployment server part, like from the putty again?
Yeah, sure. Yeah, sure. Let's say in this way, Gokul, Krishna, Sumer, you are sitting in a 3 different location, right? Now I have to install VLC Media Player. I'm just giving you one example. I want to install VLC Media Player in all of the machines. So I am in India, or in India I'm in Pune. How I'm going to do that? You tell me how I'm going to do that. I will log into your system. So first, so one by one, I'll log into Sume's system and I'll install VLC, right? Again, I'll come out of this system. Again, next time I'll log into Gokul system, I'll install VLC Media Player, I'll come out. Next time, I mean the third time I'll log into Krishna system, I'll install VLC Media Player, I'll come out. Like that, if there are 3 systems, it's okay. I'm well and good to logging, installing, having fun and coming out, it's okay. But let's say if I have 100 users like you guys sitting in a different location, so do you expect me to log in 100 times to each and every system and install it and then come out? No, right? This is not efficient. Okay, if I'm good for 100 times, it's okay. But what will happen if I have 1,000 servers, 1,000 employees? If I have 10,000 employees, what I'm going to do? Do you expect me to log into each and every server, install and then come out 10,000 times? Instead of doing that, what I'm going to do, I am going to install VLC Media Player in my system, and from here I'll make the configuration file. I'll make the configuration file in my system like a script and I'll push it from here. So the moment I'll push it from here, it will go to all the 1,000 systems and it will log in automatically. I don't have to do anything manually. It will go and log into all the 1,000 servers. It will install a VLC media player and it will come out of that. You got the point? So this is known as deployment server. So with respect to Splunk, all the universal forwarders are having two IP addresses, right? For heavy forwarder 1 and heavy forwarder 2. If it does not have the IP address, then how it can send the data? So it has got two IP addresses in its configuration file. So if if two more heavy forwarders have been added, it means we have total 4 heavy forwarders, right? So the newly added heavy forwarder information has to be written, has to be updated in each of the universal forwarder configuration file, right? So in order to
Okay, now, I got that doubt clear. Now I have another one. So instead of like maintaining like 4 different heavy forwarders, like uh, to be cost effective, like why don't we maintain a big one server,
that is true.
hyper?
Yeah, that's true. Let's say you have one server and that server is down. For some reason, that server is down. Okay, that server gets crashed. It means you have lost everything. Okay, it's lost everything, right? Or not? You have one laptop. Then why do so you have 2 TB of hard disk? Why do you go for the external hard drive then? Why do you go for the backup hard drive? So this is the same case. If I have one heavy forwarder, I am totally agreeing with your discussion, with your argument that instead of 4 heavy forwarders, I can have one big heavy forwarder with highly configured, with highly configuration. But what will happen if that heavy forwarder goes down? Your connectivity will be lost from the UF to the HF. If the connectivity is lost, then everything is lost. Let's say I'm assuming we have 2 heavy forwarders. So if one of the heavy forwarder is down, at least the data will be coming through the second heavy forwarder. You got the point?
Okay,
At least the
yeah.
data can come through second heavy forwarder because the first heavy forwarder is down. If all the heavy forwarder is down, then nothing can be done. Okay, then nothing can be done. No one can do anything. But still, just to minimize, just to mitigate the risk of failure, we have more than one heavy forwarder in place. Not even heavy forwarder, everything. Even we cannot have one indexer. We cannot have one search head. We cannot have one stuff, right? So that's the reason. Now the deployment server, so this is a deployment server and all other components will act as a deployment client. Now I'm going,
Can you make this architect like this thing in a hypervision?
yeah, in hypervision also. In hypervision, could you please, extend your question, in a bit more clear way? Hello? Hello?
Like, is it possible to make the entire architecture in the hypervision like
Virtual machines? Hello?
yes,
Yeah, yeah,
yes.
yeah, yeah. It is possible. It is possible. We have a concept called Splunk Cloud. So we can do that as well. In the cloud, we can have 4 or 5 virtual machines, and then we can make the same architecture in the cloud itself. That is very much possible. That's very much
Okay,
possible.
okay.
Okay? Not only
I
we
got it.
need to have a physical existence all the time, physical servers needed.
Okay, got it.
Okay. Now, I have a question to you. Now, you tell me, and I hope you will answer me. So let me take one more color. Instead of, now we try to understand my question, you all three. Instead of having universal forwarder, okay, instead of having universal forwarder in the application server, I can have heavy forwarder directly installed here, right? I can have it. Hello, is it possible? I can install heavy forwarder also, right? Directly. And in the heavy forwarder, I will do the logic for parsing and filtering, and direct I'll take the data to the indexers. Okay, it means This step should not be there. Okay, it is possible. It is possible. Then why the hell we have the universal forwarder? You got the question? Instead of having universal forwarder in the application server, we will install, or we can install heavy forwarder in the application server itself. So what will happen? We will write the logic of the parsing and filtering there itself, and then once the data is filtered and parsed, the data will directly come to the indexers through load balancer. So we can exclude this string from our architecture, right? This step from our architecture. In architecture, we'll have only this heavy forwarder, load balancer, and it is coming to the indexer directly, and we'll have the search head. Now, why the hell we have universal forwarder in place then?
I believe that you cannot install. We can install heavy forwarder, but like we don't need heavy forwarder for like every single small server. It is like, as you said, it is like a heavy instance,
Very
and
true,
like it
very
is.
true, very true, very true. Right, that's true. See, in a server, if any application is running, it means that application is consuming more memory and more CPU, right? So heavy forwarder is also a heavyweight application, heavyweight Splunk instance. So if I install heavy forwarder in a heavy application running server, what is going to happen? Two heavy applications are running at the same time, and they are trying to consume more memory and more CPU at the same time. So either of these two applications will crash, or either of these two applications will slow down, or anything can happen. So we do not want to take that risk. So that's the reason heavy forwarder will not be installed in any production boxes. It is recommended, not mandatory. It is recommended. Okay. So if there is a server in which you have got a small application running which is not consuming a very heavy CPU and the memory, you can go ahead and install heavy forwarder directly to that server because it is not going to impact the performance. But if you have a heavy application already running, then on top of that, if you install heavy forwarder, it is going to impact the performance. Got the point? Hello?
Yes.
Yeah, you got the point now?
Yeah, got it.
So this is all about the architecture of Splunk. So what else we have learned? We have push mechanism, not the pull mechanism. We have universal forwarder, we have heavy forwarder, indexer, searcher, license master, and deployment server. What is universal forwarder? Universal forwarder is nothing but it is a forwarder. It's a lightweight version of Splunk which takes the data and forwards the data to other end. That's it. It does not have graphical user interface enabled. Number two, heavy forwarder. What is heavy forwarder? Heavy forwarder is also a forwarder, but it is a heavyweight version of Splunk, and it has the graphical user interface enabled. It can forward the data from one end to another end, as well as it can parse and filter the data. Parsing in the sense we can mark the data, we can play with the timestamp and so on, and filtering the data in the sense we can discard the unwanted data to be stored in the Splunk server so that it can only, so that it cannot or it will not violate the license capacity. Okay, what is indexer? Indexer is nothing but again it's a full version of Splunk, it's a heavyweight version of Splunk instance. This is a place where the data is getting stored, right? What is searched? Searched is nothing but a heavier version of Splunk. It has got graphical user interface enabled so that end user can easily see the data what is stored in the indexers. So all the development activity is being done in the search head. All the development activity is being done in the search head, and so developers are starting their job from the search heads. So this is the place of the developers, and from this place to this place, now you can see here I'm just making a border. From this place to this place, this is a job of an administrator. Configure the data onboarding the data from application server to indexer. Onboarding the data from application server to the indexer. This is a job of an administrator. Okay. Once the data is in place, is stored in the indexer, then developers come into the picture. They fetch the data and they start developing the dashboard with the help of SPL, Splunk Search Processing Language. Now, what is deployment server? If I want to make any changes in the configuration file of any of the components in the Splunk architecture, then instead of going and logging manually to each of the component in order to change the configuration file, we will make use of the deployment server. In the deployment server, we will make that file, we will make that changes in one file and we will push it from here so that the same changes will be applied to all the clients wherever we want to make the changes. Now the license master is nothing but a server in which we will install or upload, not install, you can say we will upload a small license file which has got .license extension purchased from the Splunk, and we will upload it there. The moment we will upload it, it becomes a license master. And to all the license slave, we will give the path of the license server so that they'll all connect to the license server. All the license slave will connect to the license server or license master, you can say. We don't call it as license server, we call it as a master slave relationship. Okay, so this is all about the architecture of Splunk with 5 or 6 components. I hope you don't have any more questions. If you have, you can throw your questions to me right now.
I have one question.
Okay.
How deployment server is getting accessed?
Okay, how it is getting accessed? When I'll make this as a deployment server, I will make all other components as a deployment client. Okay, so at the time of configuring all the components as a deployment client, we will give the IP address of the deployment server. We will just let them know, boss, you have to take the configuration from this server. Boss, you have to take the configuration from this server. Okay, so at the time of configuring the deployment client, I will give the IP address of the deployment server to each and every client. Got the point?
Okay, and do we have a graphical user interface for deployment server, or do we have to use Putty for that?
No, we do have a graphical user interface for the deployment server as well. We do have. And that is known as forwarder management. With the help of the forwarder management, we can deploy the application to any deployment client. We have. But at the time of pushing, we need a graphical user interface. But at the time of configuring the deployment server and the client, we need the CLI. You got the point? The configuration part should be done with the help of CLI, and the pushing part, creating the application, putting the configuration files in that, and then you want to push, will be taken care by graphical user interface. Yeah, please tell me. Hello? Hello?
Yeah, what was your question?
Whose question? Hello?
Oh, okay. Actually, my question was, does this deployment server has to have any agent to be installed in the application server?
No, deployment server in the sense Splunk has to be installed, right? A full version of a heavyweight version of Splunk has to be installed.
Okay.
You have to install Splunk, man. Otherwise, see, deployment server is a feature of, is a component of Splunk. So instead of using by default the feature, one of the feature or the one of the component deployment server in Splunk, you can use any third-party tool also, like Puppet, Chef, CF Engine, SaltStack, Ansible. You can use those as well for deploying your configuration. You got the point?
Okay. Yeah. Okay. So you're saying like we can install this remotely.
Yeah, we can install remotely. Yeah, we can install remotely.
So how do we install it remotely? You said something, but I didn't catch that idea.
No, not. See, what I'm saying is, this is a deployment server. You'll create a deployment server, right? So once this
Mm-hmm.
server is created, I have got the IP address.
Mm-hmm.
Now we have to configure each of the client as a each of the component as a deployment client. You got the point? I have to configure this as a deployment client, as a deployment client, deployment client, deployment client. So at the time of configuring this server as a deployment client, I have to provide the IP address of this server. You got the point? I have to provide the IP address of this server. I have to let each of the component know that boss, this is your deployment server. You have to take the configuration file from there. You got the point? Now this will act as a deployment client, client. Man, this is very simple. When you are, when you get into the job, what you do? You are an employee, right? So your friend has got a job. Your friend has got a job. He is also an employee. So some other person is also an employee. So you all three should be assigned to a manager. So you know that tomorrow if I go to the office, to whom I should meet every early morning. Tomorrow if I go to the office, you will not meet somebody else, right? You will meet to a manager to get the task. Again, after tomorrow, day after tomorrow, or after a few days, if you go to the office, again you will go to the same person where you went 1 week before. So your deployment server is your manager. So that manager is providing the task to you guys. It's pushing the configuration file to all the deployment clients. You got the point? So all other components will act as a deployment client, and at the time of configuring the deployment client, we have to provide the IP address of the deployment server. Hello?
Yes, I got it.
Okay. Any more questions?
Not from my side.
Okay. From other sides? Gokul?
Yeah, I said I don't have any questions.
Okay. I'm sorry. I just didn't hear
I
you.
just have one question, probably the basic one where you talked about the push system.
Right.
I just want to know how this how the data is being analyzed or being sent from there to the HF.
Okay. Actually,
So
okay. So there are two configuration files called inputs.conf and outputs.conf, right? In universal forwarder. So in inputs.conf, see everything is dependent on the configuration file of the Splunk. So in inputs.conf, you are going to write from where you want to take the data. Okay, from where you want
okay,
to take the data. And in outputs.conf, you are going to write the IP address of the heavy forwarder and the port which it gets connected to. The by default port is 9997. You can change it, but by default, the receiving and forwarding port is 9997. Okay. So
okay,
this information you have to write in the configuration files of each of the universal forwarder. So in inputs.conf, you will give the path from where it should take the file or the data, and in the outputs.conf, you should write the IP address and the port of the other servers. So these two
okay.
files have to be present in each of the universal forwarder.
Yeah, got it now.
Thank you. Sumit, any more questions? Hello.
No, I'm good.
Okay, guys, then no more questions. So hope we are done here. Please.
So Vikram, from tomorrow, starting from tomorrow, we are going to